Here we are.
Welcome back to another Hamza Chef Dev vlog. In this final part, we will be finally making the character changer works. If we recap a bit, we did prepare our character with the anims. We found a very quick way to set up character if we have a new character. Then we have prepared all of the data collector and save all of the path string into a PDA. Now we just have to make our player stop walking and switch the skeletal mesh and its ABP when pressing left or right.
We're on Mulholland Drive. I know it won't be long.
In the main blueprint logic, as shown in the first screenshot, everything begins with a debug input key, P. Of course, we will replace this with a more decent input, maybe with a direct enhance input or even an event trigger from a pause menu. When the player presses that key, I check a boolean called isChangingCharacter. This flag will determine whether the player is in selection mode or not. To stop the character from moving when we are changing character, we use a select float node and we switch between the normal max walk speed default, retrieve from the character movement we cast before in the beginning, or just 0 if we are in character selection. This is applied to the character movement component, effectively freezing the character, although we can see that the character is moving a little bit. For the next one is rotation. I use a select rotator node, so when isChangingCharacter is true, we set the rotation rate to 000, meaning the character cannot rotate at all. I will explain why shortly, but when the character is not changing character anymore, we select the rotation rate to default, so it will re-enable the natural turning before. The third one is we force the camera alignment. To make sure the camera is facing the correct direction, I get the world rotation of the capsule component, break it into components, adding on the yaw with the 180 degree if we are on selecting character, and we rebuild the rotator and apply it with the set control rotation. This locks the character face into the camera direction, basically camera that facing the character face, and we can see the character facing us, and we can look at the character face while we are selecting the characters. The last and the fourth one is we shorten the camera arm length. So we need a bit more close-up camera when we are changing character. Basically, we just use the usual select nodes, and we are alternating between a shortened version of the arm length when we are changing character and the target arm length default when we are not changing character. Why not just use disable input? Yes, technically there's a simple way to freeze the player control using Unreal disable input node, but for now I choose this more manual method since it gives me finer control and makes it easier if we need to re-enable specific things later. And honestly, it's still very readable and it works. And since I already cached all the default value in the part 2, toggling between gameplay and selection mode is now very clean and reversible. The second part is all about reading left and right input. This part is powered by the enhance input action, aka the move input event. Why are we just using the move event? It's basically just a direct and simple solution. We wouldn't want any other button to just switch character, and it will still work in split screen for each player in the future. When the player triggers movement input, I break the vector to the input. Usually I break the vector to the input, but here's because I copied the move action from my BP character, I just need to drag the X and Y and then put conditions from that. So X more than 0 means the player wants to go right, and X less than 0 means the player wants to scroll left. But here's the important part. If you're only pressing W or S or forward and backward, this input event still triggers, so I added a check to make sure y equals 0. So this confirms that the input was purely horizontal. So without this, the character would switch every time the player taps up and down, which is not what we want. Only after passing this condition do we proceed to the character switching logic. I also added a debug print string, and I actually debug a lot of here. The print string nodes is just to confirm the player scrolls left or right. It's super useful. The print is super useful during testing. And we are going to switch characters, right? So essentially we are switching the scale mesh. We are switching the characters from what character to what character, right? So basically just from current character to next character if we are going right, and to previous character if we are going left. And if we are using that, it'll be a lot easier if we have some kind of value. So maybe if it's the next character, we just add 1, and if we previous character, then we just subtract 1. So, and to have that value, we actually set scale mesh count as the new variable. We just use the length node, so we just measure how much we have scale mesh on hand on the PDA, and yeah, basically go from there. And to prove that we are retrieving the correct information, we just print string. From that scale mesh count, we print we have 2 characters. That means we are correct. Okay, now I'm still not sure, so we reconfirm that we are in fact can retrieve what mesh are we currently on. So we did retrieve the scale mesh just from as character, get mesh, and get skeletal mesh assets. And let's try if we can retrieve using that scale mesh name. Can we find that scale mesh name in the PDA? Right now it's still printing -1, that means it didn't found anything. And I actually just forgot, because from that get display name, from that get skeletal mesh asset, it's actually retrieving only the name of the skeletal mesh, but what we have in the PDA is basically a full path of the assets. So we need to get some kind of assets registry and then search through them. So basically we need to retrieve what mesh we are on and what paths we are on, and then find that again in the PDA. And looks like with the for each loop, going through all of the scale mesh list from the PDA and then searching the substring from that each of the scale mesh in the PDA, looks like it's working. It's now printing 0, that means correct. We are on the first character, which means squirrel, because squirrel is the first one, remember? And yeah, I guess now we can retrieve the number. And of course the number is 0 because everything starts from 0, and our count is 2, that means we need to subtract 1. So it starts from 0 and then 1, and then now we have the correct calculation on which character are we on. And from that, let me tidy this up a little bit, and then we just set the scale mesh current as a new integer variable, and then we will use this scale mesh current and we will manipulate it. When we hit next, that means we are adding up, and when we are previous character, that means we are subtracting 1. To make sure the value stays within the range, we clamp it, but it's not a simple clamp. So we have 2 functions. If we are adding up and it's reached the maximum number of the integer, aka the scale mesh count, the one we just set up before, we reset the integer to 0. And it's the other way around when we are going to the previous character, which is we are subtracting 1, and if it reach the minimum number of the integer, and aka 0, we reset the integer to the max number of the integer, aka scale mesh count. Also, I actually added another variable at the end. You can see there is actually the scale mesh change. It's just another variable, so it doesn't clash with the scale mesh current, because scale mesh current is retrieved when we are pressing left or right. I'm afraid if we just change that value and then it's still changing, we can stuck on the endless loop, so we just use another variable.
We are one. Can't escape from this feeling inside you.
Now it's time to apply that selection in-game by updating the mesh and animation blueprint in real time. Once we updated the scale mesh change index by moving left or right, the switching logic kicks in. Step 1, get the scale mesh, the skeletal mesh. We use the current index as a key to get the actual skeletal mesh from scale mesh. And step 2 is using that skeletal mesh as the key to the animation blueprint string in the PDA. And of course, to retrieve that string from the PDA, we basically just need to grab the scale mesh change that we set before. Now we got the scale mesh as the key to search the ABP. We retrieve the path and we make the soft class path from that scale mesh with ABP strings, and then we convert to soft class reference and finally load it in the async load class asset. And when the asset is finally loaded on the complete node, now we load the scale mesh. So we make a to soft class path reference and we make soft object path from the scale mesh path. Now we are finally loading both the scale mesh and the ABP to the memory, and we are ready to set both the scale mesh and the ABP for the characters. And out from the complete node, we just need to set the skeletal mesh from the as a character target mesh. We set the skeletal mesh assets, but we actually need to cache first from skeletal mesh, and then that skeletal mesh actually need to be the new mesh. I forget right here, we'll come back to this first. And we set the anim instance class from the assets that we load using the ABP. When I test here, we can see that the character is gone, and looks like that is because we succeed switching the ABP but not successfully switching the skeletal mesh. So after we connect the skeletal mesh, this should be working. Yep, it's working, but we can see that somehow we changing the characters too fast. When we are not finished changing in the characters, it's already changing. And I also forgot that I haven't updated the scale mesh current from the scale mesh change. I mean, we successfully changed the character, so the scale mesh current is we need to update it, but I guess it's still some kind of rapidly changing still. So I think we need a guardrail, so I add is changing character still. The concept is if we are still on the process of changing characters, don't receive any commands. So in the beginning, if there's a changing character and we are not still on the progress of changing characters, then we are continuing. If we are still changing characters, then don't. At the beginning, we tell that yes, we are still in the process of changing character, and we tick that off when we are finished. Somehow it is still changing too rapidly, but then I figured out adding a delay fixes things, so it works fine. The only thing I forgot is just to rewire when we are going to previous character, and once it's all connected, it's working great, and it's finally finished! The character changer is finally working great. We can switch characters and we can add characters easily. After how many videos? I know that it might be get very boring, but I hope some of you might appreciate all of the technical details of these 3 videos on how to set up character changer. Thank you very much. See you in the next video, see you next content. Don't forget to subscribe, like the video, follow all of our social media, and thank you for watching.